We were looking at Frank Lloyd Wright's second career, one might say, that when he came back in a major way onto the architectural scene in America in the 1930s, for example, with Falling Water. These are in the mid-1930s, Falling Water, the Kaufman House in western Pennsylvania. And can we have the lights down, or maybe I think I'll let you adjust those. Thank you. And on the right, we see the plan of his Jacobs House, also from the mid-30s. That's the first main representative of Wright's attempt to apply his principles that went back to the prairie house style and his principles of organic architecture in general to more modest houses, what he called his Usonian houses. Well, one of these houses of the 1930s that he considered Usonian, even though it's different, as we'll see, in some major ways, is of special interest to us because it's here at Stanford. And that's what I'd like to look at to start with today, not give as much attention to it as we'd like to maybe, but at least want to make sure that I say something about the Hana House, which is our great architectural treasure here at Stanford. Even though Wright considered it in a general kind of way as part of this Usonian house type, mainly because it was a modest house, small, was meant to be able to be constructed rather easily and cheaply, it still is a very unusual house, certainly one of the most innovative designs of this late period of Wright. It was designed in 1937 and then built the following year for a Stanford professor and his wife, Paul and Jean Hana. He was a professor young professor in the education school, and Jean Hana was also an educator. Built on Frenchman's Road, which is off of Mayfield. And the most, I'll show a picture of the exterior in a minute or so. The most remarkable aspect of the house certainly is the geometry of the floor plan, based on hexagons, not right angles. There are no right angles that are in the floor plan itself. So it means that all the parts of the house, the walls, connect at 60 and 120 degree angles rather than right angles. And this is something that Frank Lloyd Wright had been experimenting with for some time, but it was really the Hanas were the first clients that he was able to talk into doing something so, taking the risk of doing something so unusual. His Wright's motive was primarily, I think, just to take further this idea that he'd been developing since the beginning of the 20th century of destroying the box of traditional architecture and creating dynamic and fluid space, and by eliminating the right angle, that just further destroyed the traditional box. It's so unconventional that it's a little hard to even see at first when you look at the floor plan what we're really looking at. This is the plan of the whole property here, or at least the area around the house. The house itself is just, or at least the main part of the house is this area here, and the road, Frenchman's Road, is down to the right here. The driveway comes up just to kind of walk through and understand the parts of it. Driveway comes around here, and there's a carport area here. And we're looking in the rendering that is over on the left there, one of Wright's drawings for the house. We're looking at this back part of the house as one comes in, and then here's the carport area, and the main house is here. Then there's an entryway. One moves into the living room, and you can see how all of the connections between the walls and the windows and doors and areas such as or masses such as the fireplace, core with the chimney, all of these have 60 and 120 degree angles. It's all based on a grid of hexagons, which sometimes is drawn on the floor plans. There are several different versions of the floor plans of the Hana House, and sometimes you actually see the grid. It's a grid of hexagons, and everything lines up with that grid. It's hexagons which are of this size that you see here in this area. And then one moves through originally there was a dining area here and the kitchen here, which is Wright calls the workspace in this plan. Then there was a large playroom for the children. One of the other interesting things about this house that was really quite unusual was the Wright and the Hanas, working together very closely, designed the house to evolve, to be able to change over the life of the family, that was to be very closely integrated with the way the family worked. And they had 3 young children who were given 3 very small bedrooms, but then this large playroom that could be observed by the parents, and the rest of the house. The parents' bedroom was here, and a study. But it was designed in such a way that after the children grew up and left home, that their bedroom walls could be taken down easily, and that this area would be turned into the parents' master bedroom, and the other part made a study, and the playroom become a larger dining room for more generous entertaining. And this was exactly what happened, and the house evolved in this way that was planned from the beginning by Wright and Hana. So it's a very interesting house in many respects, but certainly the most unusual is the fact, this unusual geometry that it's based on. Let's see, I think I have a slide of the interior that gives a sense of how this geometry creates this kind of fluid space that moves around, and there's an openness between the parts of the house, and of course the inside and the outside, all typical of Wright, but taken to a new height here in the Hana House. And it was in fact one of Wright's favorite houses. He frequently would come back to, whenever he'd be in California or in the Bay Area, he would stop by and see the Hanas and visit the house again. He would bring his students and apprentices, and it was he considered it one of his most important houses. When in the 1970s, the Hanas gave the house to the university, and for a decade or so it was used as the home for the university provost. But then in 1989, the earthquake did a good deal of damage to the house, and it's been closed ever since. Here's a view of the house today with scaffolding up and other things to keep it from further damage and to protect it while the plans are being made for its restoration. I've been closely involved in these efforts, the plans for restoring the house, which have been complicated, both from an engineering point of view, but also in an attempt to preserve as much of the original fabric of the house in this restoration effort. And people are always asking me, when is it going to be restored? The latest plans we've had, unfortunately, certain delays, but now it looks like the construction will actually start in April this year and probably be finished in a year or so. So hoping that it will be open for tours again in the not too distant future. Just a couple more views. Here's the house as seen from Frenchman's Road, and so it still, of course, can be seen from the exterior. In fact, it's probably okay to walk up the driveway and to get a little closer to the house, technically. And it's got some chain link fence around it, but if you want to try to go up and see it from the outside, probably won't get into too much trouble. And here, a view from the upper side of the house. It's built into that hill, as you can tell from the other photograph. And typical of Wright's works, there's this intimate relationship with the natural surroundings, built into the brow of the hill, this idea that he had of buildings being intimately sort of tucked into their natural site, and even built around trees and other topographical features. Certainly, it's one of Wright's wonderful houses, and hope that it will be available soon for tours again. Wright's fascination with non-rectangular geometry was very strong especially starting in the 1930s, and all of his later works deal with this question one way or another of unusual geometric systems, which he explores. Hexagons, as here in the Hana House, octagons, triangles, and also circles. And let's jump ahead to another one of his certainly most famous works of his late period, which is the Guggenheim Museum in New York. Built in the 1950s, just toward the end of Wright's life. But he had designed it actually, or started designing the Guggenheim Museum in the 1940s. It just took a long time for it to be completed. And here, of course, it's circles, which he's using as the underlying geometry of the design. Everything based on circles in one way or another, creating this really dynamic interior space that focuses around a spiral. As you can see, if you look at the section drawing down on the right here, on the right-hand side, the spiral spirals up and out as it rises, and the actual exhibition space, or most of the exhibition space in the Guggenheim Museum, which is a museum for contemporary art, is on these the ramps which spiral up as part of the reinforced concrete structure of the building that, of course, you see very clearly expressed on the outside. I have another interior view looking across, and you can get a sense of how these ramps work and create this very dynamic and fluid space where movement is strongly suggested, and it's a truly exciting space. In fact, some people have criticized the Guggenheim Museum. The main criticism is probably that the building is so exciting that it detracts from the art, and also there have been criticisms that it's the spaces, these ramps, these slightly sloping ramps and the walls around them are not necessarily the best format to display paintings and other contemporary art. So there is certainly there has been questions about just how well it works as a museum, but there's no controversy about the power and the excitement of the building itself. And as I say, in some ways it almost is too powerful for the art in it. It's certainly one of the great works of architectural sculpture of the 20th century. What's interesting also in connection with the Guggenheim Museum, and this gives it a local connection again, like the Hana House, is that there's a kind of mini version of the Guggenheim Museum in San Francisco. And here it is. Oh, well, this was another view of the, that's obviously not in San Francisco, that's another view of the Guggenheim, where you get this sense of this dynamic movement. Here's the one in San Francisco, looking down into onto the curving spiral ramp, as similar to the view on the right. And this is a little store, little shop called the V.C. Morris store, at least that was the original name, that Wright was hired to build in the late 1940s. And it's right off of Union Square in San Francisco on a little street called Maiden Lane. And in the late 40s, when Wright did this, he had already designed, or had started designing the Guggenheim Museum. As I mentioned, he started working on it in the 40s, but it wasn't built until the late 50s. And in the meantime, he kept thinking about it, and he was excited about the idea. And so I think he clearly, when he got this little job in San Francisco for a shop, he tried doing it on a miniature scale. It was kind of a dry run, one might say, for the Guggenheim. It's because it's such a small shop, it's hard to photograph inside, but you can get a sense that there's this spiral stair that rises up. And let me just show it from the outside. It's gone through various different uses, and different shops of different kinds have used it. The last time it was an art gallery for a while, which I think has just gone out of business, and I'm not sure. I haven't been there just in the last month or so. I'm not sure whether someone else is there. And whether it's open. But certainly when you're in San Francisco next, go and see it, at least from the outside, and see whether it's open, and if so, go in and see this mini Guggenheim Museum on the inside. But as you can see, it's very different on the outside. He didn't try to replicate the Guggenheim on the outside. For other reasons, he wanted to have this very simple facade, this brick wall, but with this great arched entrance, which at least suggests the spiral form inside. And but also, I think, is a kind of homage or recollection of the work of H.H. Richardson with these great arches in stone and brick from the late 19th century, whom Wright admired, of course, greatly and acknowledged as one of the great masters of early modern architecture. In fact, it's also interesting to mention that when Wright was here at Stanford in the 1930s to design the Hana House, that Paul Hana later told me, recollected, that when they would walk through the quad, Wright praised the architecture of the quad, and specifically said that it reveals the hand of the master, was the phrase that Paul Hana recalled and told me that Wright actually said about the Stanford quad, and apparently what he meant by that was H.H. Richardson. And of course we know that Richardson himself was not the architect, the direct architect of the quad, but it was clearly in his style, Wright, and designed right after his death by his associate Coolidge. And so Wright recognized that and recognized the architecture of the quad as being in the style of Richardson, and considered it perhaps the greatest university architecture in America, as recalled to me by Paul Hana. Well, finally, one other building, late building by Frank Lloyd Wright, that's again in the San Francisco area, which is the Marin County Civic Center, built right at the end of the 1950s. And in fact, when Wright died in 1959, the building had just been begun, and so it had to be completed and supervised by associates of his. And some people have suggested that the details and other parts of the design, the details of it, are not worked out with the same kind of standards or care that Wright himself might have given it. But the basic concept is certainly Wright's, and it's an extremely bold concept of this Civic Center. It's a government building for Marin County that includes the county offices and courthouse and so forth. Are arranged by Wright along two very narrow, long structures, and here we see them, that are connected by a round domed library. The county library is under there, and then these two wings extend out, and within those the offices and various facilities are arranged off of a central corridor, which rises in some cases 2 or 3 stories, depending on where it is on the hill, and then with a skylight above. So it's a very ingenious and unusual kind of scheme. But the notion, the underlying notion, I think, is that it's to be a kind of bridge, that rather than filling in one of the valleys or cutting down one of the hills to make a level site, that it leaves the hills just where they are and acts as a kind of bridge between them. And there are even the arches that one sees in this center are like the arches of a great bridge. And so right up to the very end of his life, in his early 90s, he was still had the innovation and the fertility of imagination to come up with these amazing schemes. So also, we in the Bay Area are lucky to have a number of examples of Wright's buildings. Here, the Hana House in San Francisco and Marin County, and a couple of others. And in fact, this area is one of the best represented with Wright's works, after the area around Chicago, and I guess in Wisconsin, and maybe in Los Angeles has a number of Wright buildings too. But we in the Bay Area are well represented, or Wright's buildings are well represented here. Well, by this time in the 1950s, most young architects in America had become advocates of the international style and considered Frank Lloyd Wright a bit out of touch. They recognized his genius, but many considered his work somewhat eccentric, a little old-fashioned, not pure and rigorous enough in the international style sense of creating universal standards and being easily replicated. Everything is always very individual with Wright's work. But But soon, some of these younger architects began to move off in different directions themselves. And let me look and do a kind of quick survey of some cases of this. And one of them I'd like to look at, one of these younger architects, is Eero Saarinen, architect who was born in Finland. His father was a successful Finnish architect who actually came to the United States in the 1920s. The reason his father came, whose name was Eero Saarinen, came to the United States was that he had won a prize in that 1922 Chicago Streetsman competition. Remember, that we looked at that was entered by people around the world. And the second prize, I believe it was actually given to this Finnish architect, Eero Saarinen. And even though he didn't end up building the building, first prize, but still it was enough to bring him to the United States, and the rest of his career was here in America. So his son Eero grew up in America, studied, and then worked with his father, and then set up his own practice. And around 1950, received a major commission to really sort of establish his career, which was the General Motors Technical Center near Detroit. And here we see two views of this, an aerial view of the whole complex, many buildings as you can see. And basically, you can see that Saarinen was using that system that Mies van der Rohe had developed, or was developing in America at this time. So clearly we have this young architect aping or following the principles of the international style, specifically as introduced to America by Mies van der Rohe. This steel frame system gets filled in various ways, either by all glass walls or with brick panels or other ways of turning it, and all set out on a grid plan. You can tell from the view and the aerial view on the left that there's all underlying a rectangular grid with all of it. But already, even in this technical center near Detroit, there are hints that foreshadow Saarinen's distinctive characteristics of his later work, and especially his love of dramatic structural form, which came to be, in a sense, the signature or underlying trait of Saarinen's work. For example, if we look at some of the details in this General Motors complex, here an entryway, a canopy into one of these, the entrance to one of these buildings, supported by a single column, as you can see, a steel column, this cantilevered canopy in a very dramatic way. Or another example, a suspended stair that comes down, suspended by these very thin steel rods. Or another case of this, a water tower that's on this site as part of this technical center that's supported on these three steel tubes. And in the 1950s, Saarinen explored his interest in structural forms and unusual and dramatic structural shapes in several important works, which really caught the attention and imagination of much of the American architectural community. He had a great influence on architecture in the post-war years, after the Second World War, even though he did not practice very long. He lived only about a decade. He died tragically young in 1961, really the height of his career. And so he didn't do a lot of buildings, but they're all really quite remarkable. Quickly. Here's an auditorium and also a chapel that he designed at MIT in Cambridge. The chapel is over there and interesting as well, but it's mainly the auditorium I want to point out, where he takes a structural system and refines it or pushes it to its limits and uses it in a very dramatic way. The whole auditorium, spanned by or covered by a thin concrete, reinforced concrete dome, but which, as you can see, is supported on very small points. There are only three of them. It comes down to 3 points, which almost hard to understand how it can all be supported by this. But for one reason, it's a very thin concrete shell that Saarinen worked out with engineers just how you could do it in the most efficient way, and he really began an interest among American architects in thin shell structures like this. Saarinen was a very well-trained engineer himself and had a real intuitive kind of sense of engineering, and this comes out in his work during the 1960s. In the next work, where he develops this idea of thin shell concrete structures, he makes it much more complex and dramatic in a sense. And this is the perhaps the most famous building in some ways, is the TWA terminal at Kennedy Airport in New York, built in the mid-1950s. With these concrete dome shell structures, which again come down and are supported on relatively small points. But here it becomes, as you can see, he's working and sculpting this, really creating it almost, treating it almost like a sculpture, so that these forms have dramatic and unusual shapes, which, as many people pointed out, and I think he himself even acknowledged it, is really inspired by the idea of suggesting flight. And there are parts which have a kind of bird-like shape here, where with the wings extended, and there's this sense of movement and flight. It's very beautifully elicited and suggested in these concrete forms. Many of the parts cantilevered in remarkable kind of ways. Closer view of this building, really wonderful building. Worth choosing TWA to fly into Kennedy Airport for, just to be at that building. And what's interesting, I think, is, well, a number of things. One is, first of all, this is, of course, very, very different from the international style, not only in the shape of it, that it looks different. International style buildings usually don't have these kind of unusual forms, but also because the underlying idea of that is a very individual form, that it's not standardized in some way, that it's expressive also of these feelings. There's kind of expressionism in it. The whole tradition of architectural expressionism in the 20th century is something that I talk about more in my course on 20th century architecture, because it's mainly a European phenomenon. But this certainly can be thought of as part of this notion of expressionism in 20th century architecture. And which is a very different, sort of at the opposite end of the architectural spectrum from the international style. But especially this idea that each building is individual and expressive, not standardized, is pointed out clearly if we compare this with another airport terminal building, which Saarinen also designed in Washington at Dulles Airport, and we'll see that it's completely different. You see, an international style architect would have the idea that that if you have a program like an airport terminal, you figure out the most rational and efficient and the best way of dealing with it, and you come up with a form. And then if you're designing another airport terminal, you'd use basically the same form, maybe just modified because of local conditions or whatever. And that's certainly the approach that someone like Mies would have. Here, Saarinen, interested in these unusual structural forms, dramatic individual forms, comes up with something completely different for his Dulles Airport terminal. If you look at the form, you can probably have an idea of what the structural system is here, just from seeing the overall shape. Does anyone have an idea of, want to guess about what the structural system being used here is? Pardon? It's a suspension system, right? So it's really exactly the opposite in some ways of the TWA terminal at Kennedy Airport, which is concrete, which is really dome structures made of concrete, but it's really basically a dome. And a suspension structure can be thought of in some ways as the opposite kind of structure, whereas a dome is in compression and the forces are directed down toward the ground. A suspension structure is in tension, and the forces tend to pull in the opposite direction. All of the forces are really opposite, domes versus suspension structures, really like a suspended bridge. There are cables up here that support the roof, and you can see that A dome would never, you wouldn't build a dome in that shape, of course, because it wouldn't be structurally efficient to do that. It tends to want to collapse. You want a dome to be going the other way. And so everything is opposite in a suspension structure. And one can maybe see that a little more clearly if you look at this detail where the columns come up and support the cables at the top. Saarinen creates these very interesting connections there, so you can see, or to make more dramatic, this connecting point where the cables are supported by the columns. Also, he shows clearly that the force of the cables tend to want to push, create a force which is pushing in this way, and that's why he has the cables which lean out. If you were supporting a dome with buttresses like that, if you think of like flying buttresses on a Gothic cathedral, they'd be going the other way. And so the very shape of the building is an announcement. It tells us what the structural system is underneath. But completely different from the one in TWA, so it's like he's taking each commission as an opportunity to do something completely different. Well, Saarinen produced some other remarkable designs in his brief career that was cut short in 1961. But I just want to show one more, perhaps is certainly one of the most dramatic designs, which is the Gateway Arch in St. Louis. I'm having a little trouble. Buttons here. Okay, here we have these two views of the Gateway Arch in St. Louis along the Mississippi River, built as a symbolic statement of St. Louis and the gateway to the west, as a symbol of the city. It's probably one of the most memorable and dramatic architectural forms that has a symbolic function in American architecture. One thinks of the Washington Monument and maybe some others, but we don't tend to have a lot of these kinds of symbolic buildings in America, things like the Eiffel Tower in Paris. This is certainly one of the greatest. The scale is so large on this structure that it's really hard to comprehend, even when we see pictures of it with the buildings in the foreground, as on the left there. Get a sense by the people down here at the base of this. It's a beautiful form itself for this parabolic arch, or catenary arch, with the section, the shape of the steel legs of this, a triangular form, which however changes as it rises up. The actual dimensions and the shape change. It gets narrower up at the top, reflecting the forces that are involved. And it also is a form not just to look at, but to go up in. There are elevators inside, entrances at the base that are below ground, and I wanted it on the other side. Here, you can see here the windows, the observation area up there. So it's really a extraordinary structure, one of the most, let's say, dramatic, symbolic structures in America. But let's move on to a different kind of direction that architecture was taking in these post-war years, and look at the work briefly of the architect Louis Kahn, who at about the same time as Saarinen was exploring different ideas that have been, and all of these things have been important for American architecture since then up to the present time. One can see the effects of the ideas of Saarinen and his designs, and also of Kahn, maybe even more so in the case of Kahn. It's had a very strong mark on contemporary American architecture. Though it's a little harder to describe, or the concept is perhaps a little harder to grasp than in the case of Saarinen. Here we see one of Kahn's early buildings. It's an art gallery at Yale, which he built in the early 50s. which was essentially in the international style. When you look at it from the outside, it's very simple, and it's pretty much like a building of Nice or other members of the international style. But when we look at the floor plan of the building, we have a sense of there's a germ of Kahn's developing concepts of architecture that are to become the hallmark of his work. And perhaps the best way to explain it is to say that it deals with a clear separation of functions, the different functions that a building serves programmatically. Kahn started thinking about this, and one of the things especially that he was interested in was how contemporary architecture, especially public architecture, devoted a great deal of attention and had to be devoted in large part to mechanical systems and other kinds of activities where people, spaces, not necessarily spaces where people actually live or work, but that in a sense serve the building. Plumbing, heating, elevators, other kinds of mechanical equipment. And he realized that what most modern architects did was to just kind of put them out of sight somewhere. All of this mechanical business that was required more and more in modern architecture would be kind of stuffed away somewhere in between walls or in plumbing chases and things like that. And he wanted to have a clearer, more logical system for dealing with these parts of the building. And one senses that here in the plan of the Yale Art Gallery, where the building is divided clearly into three parts. There are two galleries here, and then there's this other area over here. But then the central section is a whole bay of the building with a different dimension that's given over to these functions which Kahn came to call servant functions. And he would make the distinction between the served parts of the building and the servant parts. And mechanical equipment, stairs, elevators, and so forth. And he developed this idea in a clearer and more complex kind of way, a more fully developed way in his later buildings. And we'll just look at a couple of them, or mainly this one, the Richards Medical Center in Philadelphia, where that really became a kind of manifesto of Kahn's ideas. And this was in the late 1950s, where and you can see the plan here. This is a research building with laboratories, research laboratories as part of the medical center of the University of Pennsylvania in Philadelphia. And one can see in the floor plan that there are these, the building is divided up into these separate areas, which are the labs, the main part of the building, the served parts. But then these other sections which take a separate form and in many cases are attached to the building like towers. You can see them clearly on the right. That either are stairways or elevator towers, or many of them are the mechanical equipment that, of course, for a building like a laboratory's research lab, you need a lot of mechanical equipment. And so this was a good type of building, a logical building for appropriate building for Kahn to explore this idea with. And so it's a recognition, on the one hand, of an importance of mechanical equipment to modern architecture, but also trying to do more than just take care of it in a functional kind of way, but to express it visually and to create a new form or a distinctive form of the building with these towers and these separate parts, so that one sees and understands, in a sense, intellectually, when you're looking at this building, that there are these different parts for different functions. In one way, it reminds us of the kind of thinking that was hinted at already way back in the 1890s by Louis Sullivan, when he talked about skyscrapers in that article we read of his, and analyzes the different parts of the skyscraper, and he points out that at the top of the skyscraper is where the water comes up, and there's a water tank, and the various kind of heating equipment is up there, and that it revolves, and so that the top of the building has a cap which is treated differently from the bottom. And you might think that, in a sense, that Kahn is just developing this idea further. Well, this is one aspect of Kahn's work. I have to other important innovations that he made that we can't get into here, but I should point out that Kahn is admired by other architects, perhaps more than any other figure that I know of in the post-World War II period in American architecture. admired for the clarity of his analysis of architectural problems, but also for a quality of beauty in his works, which is hard to define and almost impossible to sense in photographs. But let me just try to suggest it in a couple of views of another one of his works, which is also a medical research building. It's the Salk Institute at San Diego, right on the coast, and the programmatic functions of this complex, which also involves labs and offices, but also in this case quite a few private studies for researchers who are brought to the Salk Institute as visiting scholars and so forth. So there had to be a lot of spaces for the researchers actually to have as offices and private studies. And all of this is handled ingeniously and organized on two sides of a central courtyard on a hill overlooking the ocean. And here we see the courtyard, two views of it. One as you start to rise up into it, and then on the left as you see in this courtyard. The water is used ingeniously here too as well, running through it in fountains and then a stream of water that goes down right into the center of that courtyard. Amazing quality visually. And these structures that you see on either side of the courtyard are what Kahn called the thinking towers for these studies for the researchers. And then beyond those are the labs where they would work together, and they have a different, completely different kind of design. So the design of each part of it grows out of the function. That's this underlying concept of Kahn. So it's all very logical in that programmatic sense. But when one is in this space, looking over the ocean, depending on the light and other conditions, one really can experience a very powerful, almost a mystical sense of beauty. I've been very moved by this space when I've been there, of beauty that derives perhaps from the proportions of the space, and the relationship to the building, but of course also the relationship to the environment, the way Kahn handles the light, or foresaw how light would reflect off of these parts. So it's a reminder that architecture is more than just the solving of utilitarian problems, or at least can do that. And a reminder also that when we say form follows function, as Sullivan did, function can mean more than just the practical problem. Sullivan certainly himself interpreted it in that way, as Kahn would have. I'd like to turn now briefly to another building of this period in the 1960s that was perhaps the most publicized architectural project of the time in America, which is the Boston City Hall, a new city hall for the city of Boston, for which a competition was held in the early 1960s, 1962, I think. And the winning design, it was a highly publicized competition like that the Chicago Tribune competition 40 years earlier. The winning design was by two young architects, really unknown architects at the time, named Coleman and McKinnell. And here we see the finished building in downtown Boston. And on the left, one of the competition drawings. Very impressive architectural drawing for the competition. And whenever we look at an architectural drawing, we want, of course, to ask ourselves what kind of drawing is it. So in this case, what is it? What kind of drawing? Okay, one-point perspective, you're saying, right? And that's true. Is it anything else? You know, it's a section drawing as well, and that's one of the reasons I'm asking, to point out that these drawings can be combined. I think I made that point in that little handout right at the beginning of the course about the basics of architecture, talk about the nature of architectural drawings, and that they often can be combined. Here you have a section drawing, and clearly a section is cut through floors and walls, but it's rather than a true section drawing in which you would, behind the parts that are cut, everything would be shown in elevation, that is without any perspective, it would all just be flat and at the same scale. Here, behind the section, it's drawn as a perspective drawing, a one-piece section, it out. And so it's sometimes called a section perspective. And the building itself exemplifies, the Boston City Hall exemplifies a number of the approaches that current at the time, some of which we've seen, such as that separation of the building into different functional or programmatic forms in the work of Kahn. The offices up at the top of the building, given this form with the cantilever out a bit from the building, with these divided by these fins or piers that suggests that they're all offices are all the same up there. And then the more public spaces is city council space, the mayor's office, and so forth, in these concrete forms that cantilever out and have a different kind of shape, this dramatic one, and all of them held up, raised above the ground as great concrete piers. It partly reflects the work of Le Corbusier in Europe at this time. Also, there's dramatic structural forms, as in Saarinen's work, these great reinforced concrete cantilevers, and also a massive kind of sculptural quality. This the heaviness of the building, and they suggest partly a reaction against the thinness and the insubstantiality of the international style that people were getting to be tired of by this time in the 1960s. And parenthetically, I might just mention that it's interesting that the publicity surrounding this design and then the building when it was constructed in Boston was such that in succeeding years it was widely publicized in America, illustrated in all the architectural magazines and other magazines as well. And in succeeding years it had a remarkable influence on building around the country. So the result is that one frequently sees little copies, one might say, little Boston City Halls around the country, usually dating from the 1960s and 70s, but sometimes later than that. And here we see one of them, a building in Oakland, a bank building where these cantilevered upper floors and those kind of fin-shaped piers that hold the whole thing up are clearly inspired by Boston City Hall. So it's an interesting example of what we might call kind of formalism, where a form takes on a life of its own and is copied and used for various buildings regardless of their functions. This has been typical of really, I think, all of the decades since the Second World War. We still find this kind of formalism very a powerful element in contemporary architecture. But the Boston City Hall also illustrates a larger phenomenon of the period, very different. It's more in the realm of city planning, because this the city Hall in Boston and also the whole area around it, what's called Government Center, was part of a massive redevelopment project in downtown Boston. That's a prime example of what at the time was called urban renewal. I want to at least mention or say something about urban renewal. It's a process in which a large area of the inner city, usually an area that was considered a slum or blighted in one way or another, would be taken over by the government, by eminent domain. The buildings would be torn down, and a brand new plan would be executed, either public buildings, as here in Boston, or public housing or commercial buildings. Often, as in the Boston Government Center project here, the new plan involved monumental buildings set in large areas of open space, as you can see here. This all reflected attitudes about city planning that went back to the theories of Le Corbusier in Europe and other people from the earlier 20th century, but also perhaps the city beautiful ideas that have been strong in America about urbanism, creating grand public spaces. But in the starting in the 1960s and then powerful in the 70s and continuing up to the present time, there's been a strong reaction, I think, against this type of urban renewal. And the most articulate critic, one of the first, was Jane Jacobs, who wrote a book, The Death and Life of Great American Cities, in 1961, which attacked the underlying premises of much of this whole urban renewal concept in a powerful way that had a great deal of effect on people's thinking ever since. And she is certainly one of the great figures, even though not an architect, or strictly speaking a city planner herself, who's had a great effect on thinking about architecture and urban planning in America in recent decades. And there's a selection, of course, from her book, the introduction to it, that was it's in the Reader for last week, I think. Also, in the 1960s and 70s, a reaction developed against the highway program in America, began to react against it. The highway program, which supported by federal and state funds after World War II, had produced this amazing highway system in America, unlike anything else elsewhere in the world, that in America, of course, contributed to one thing, the growth of the suburbs around American cities. These highway designs were tremendously bold achievements. Sometimes I've thought that people in the future may consider these highways of the mid-20th century in America the most remarkable creation of our time. To the extent that they survive, they're just amazing when you we're so familiar with them, driving on them all the time. But just as engineering achievements on the level of something like the Egyptian pyramids, there's certainly more money and effort from a government point of view has been expended on highways probably since the Second World War, at least in terms of infrastructure or building in the American environment than anything else. But, of course, they were products of certain assumptions which are much in doubt now. Assumptions such as the desirability of unlimited growth and the whole suburban phenomenon and the availability of cheap energy to drive on. So, but no examination of the history of American architecture and city planning can ignore, of course, the phenomenon of these highway programs. Well, in the last couple of decades, these and other assumptions of American architecture and planning have been questioned, of course, and American architecture has splintered into several different movements and directions, that, some of which are hard to identify clearly or define easily, some of which are rather esoteric or vague, some of them questionable, at least in my opinion. And I'll try to describe some of these more recent developments in the last lecture next time. But now, in the remaining time today, at least for some of it, I'd like to say something about another architecture designer who sometimes I have trouble even fitting into my courses. It's difficult to fit into categories or movements. And so sometimes he gets left out of courses or books on American architecture. Strictly speaking, he was not really an architect. But there's something very American about him, so I wanted to include him this time in the course. And this is Buckminster Fuller. Certainly one of the great figures of American design, but as I say, it's hard to know just what to say about him, or where to include him. It's not, in some ways, it's not hard to know whether he's really an architect. He's rather, I guess, in that tradition of eccentric American inventors and visionaries, of which we've seen a number over the, especially in the 19th century, maybe, people like Orson Square, Fowler, and the Oakland. Buckminster Buckminster Fuller was originally trained as an engineer. He's a slightly older generation than the other people we've been looking at. And as early as the 1920s, he had made some remarkable proposals for fabricated houses, prefabricated houses, that he called, in a generic kind of way, he called these the Dymaxion house. Fuller liked to make up these terms, and Dymaxion was dynamic, of course, and maximum was trying to maximize the efficiency, the dynamic potential of these houses. And here we see on the left a model for one of these Dymaxion houses of his, and on the right an actual prototype that was made for a different version of it. He went through a number of different stages, which was actually went into production for a while, or he was hoping it would, and the problems became very popular. But this is a prototype that was assembled in the late 20s and up until the 40s. I think the prototype on the right is from the 1940s. And these houses are all made out of metal and materials that can be fabricated in factories efficiently. They can be assembled easily, erected anywhere, and also disassembled and then moved to some other place. And so they certainly reflect certain international style concerns of the period, the ideal of prefabrication and factory construction, of universal solutions, a building that can be built and be appropriate in almost any site, so it can be mass-produced and be cheaper. But in some ways, Fuller takes these ideas, which were being explored in Europe, and they're even more extreme. He takes them to their logical conclusion in a way that even the Europeans never really did anything quite this extreme in this regard. Also, I think these designs by Fuller seem to reflect that American tradition of mobility, of buildings that can be moved around. There's this American sense that you may remember the quote that I quoted, I think, at the beginning of Vincent Scully, when he talked about that American tradition of mobility that he suggested goes back to even to Native American architecture, the mobility of the teepees of the Plains Indians and so forth. And this continues in America in the 20th century with things such as mobile homes. And so one could think of Fuller as being part of that American mobile tradition. Also the American spirit of inventiveness. And he can, in fact, be compared, I think, with Orson Squire Fowler, with the phenomenon, you recall, of the octagon house that he promoted in the 19th century. And there's some remarkable similarities. You remember that with Fowler and his octagon houses, of which we see some of the plans for these, he came up with this shape of the octagon as the perfect shape for a house because of certain technical reasons, and the fact that it would enclose a larger volume for the amount of exterior surface, and it was all this there was a kind of a technological rationale behind it, without much thought to how one would actually live in these houses, and as a result, people had trouble actually arranging the rooms and figuring out how you're going to have rooms inside an octagon. You get all these funny kind of plans that really don't work too well in terms of actual living patterns, how you put furniture in them and so forth. And one of the problems was that Fuller had exactly the same, it was exactly the same phenomenon, where he comes to these shapes of these Dymaxion houses for these technological reasons, and how the ease of manufacture, prefabrication and so forth, without really thinking about how people would live in them. And the same thing happened. And one of the reasons I think that they were not very successful is that you get these funny pie-shaped rooms, and it's hard to arrange furniture in them and so forth. And so it's there's a typical kind of thinking or pattern or mentality between these two architects 100 years apart in some ways. But Fuller's career is much more important than this, because this was only one of his innovations and his ideas. He was full of inventive and ingenious notions, some of them really quite remarkable. And in fact, he's best remembered, I think, or known for the structural systems that he developed after the Second World War, and in particular the geodesic dome that he really invented and explored the potential of creating these domes in which are made up of assembling short members of wood or metal into triangles or hexagons. There are various possible arrangements of these. And you can see in the photograph on the left Fuller and the various models that he experimented with to explore the structural properties of different arrangements of the struts or the pieces in these geodesic domes, another term that he came up with. The result of it gives the overall dome form a lot of strength, certainly in relation to its mass. It's a kind of three-dimensional truss. And the geodesic dome, according to Fuller, could be used for any type of function. He really thought of it as something which could revolutionize architecture of all sorts. In practice, however, it's again for the problems of how one actually uses it inside. I think it's been used mainly for specialized structures, such as the one on the right. This is a building in St. Louis in a botanical garden, and it's in the large public buildings, rather specialized uses that the geodesic domes have been particularly successful. One occasionally comes across houses that are made that are in geodesic domes, but they seem to be less successful. Probably the largest and most dramatic geodesic dome ever constructed was at the Montreal World's Fair in 1967 as the U.S. Pavilion at this fair. And Fuller himself was a consultant on this, and you will see two views of this U.S. Pavilion in Montreal. Amazing form. Again, it's hard to understand the scale of it or comprehend the scale just from looking at an overall picture of it. And it's only when we see something like the photograph on the right, where we see a monorail that went through the fair, actually coming into the building and passing through one of the octagons that forms the structural system of the geodesic dome. So you can see, if you look over here on the left, you get a sense of how the scale that we must be seeing here if a monorail train can go through one of these octagons. This building, especially the geodesic dome here at the Montreal World's Fair, suggested that a whole environment, perhaps even a whole city, could be enclosed in a structural system. And this idea, in fact, was being explored by other architects in some amazing ways. Some of them bordering almost on fantasy. And the person who developed this idea, I think, and advocated it more forcefully than anyone else, was a man named Paolo Soleri, whom I'd like to conclude with today, who represents this aspect of the possibility of designing huge structures that can become cities in themselves, what came to be called megastructures, and it was a popular idea among architects in the 60s and the 70s. Paolo Soleri was an Italian architect who came to America and settled in Arizona, where he still lives, and developed his ideas there, and created a cult following. And starting in the 60s, Soleri was advocating that the population of the world, in fact, could be housed in gigantic megastructures that he called arcologies, architecture and ecology. Architects in this post-war period love to come up with, invent new words for their designs and their theories. These structures that would be so huge that it's almost impossible to comprehend their scale. In fact, it's so difficult to comprehend their scale that in the drawings that Soleri did of these arcologies, he gave us an idea of the scale of them, or had to give an idea graphically by including a drawing of the Empire State Building at scale. There that is over there, so you can get a sense of how absolutely immense these so-called ecologies would be. That would, each one of them, that could house a million people or more. To understand Soleri's motives for all of this thoroughly, one has to read his writings and explanations about these, which get almost into kind of mystical ideas that are certainly well beyond the urban planning concepts in a straightforward way. The whole philosophy Soleri brings to this. But one of his more straightforward motives was to protect the environment and ecology of the world from the threat of exploding population by packing the human race into these structures, creating population densities much greater than any existing city. And of course, we can only speculate on what the social and psychological effects of this kind of city would be, since it involves not only restructuring the physical city, but restructuring society, at least in the terms that Soleri talks about. So it's so Soleri is a very extreme form, probably the most extreme form of an idea or ideal that still has been common in much of modern architecture. The idea that the architect and the city planner maybe have a responsibility to try to solve social and political problems of the modern world on a large scale. Urban renewal, of course, was part of that. Somehow we would just come in and sweep away the past and create a kind of brave new world. And in a different kind of way, the international style is part of this idea of solving problems. Underlying the international styles, I think I mentioned with particular socialist ideas about how the problems of the lower classes and working classes could be solved, and great attention on public housing and mass production, housing for the masses and so forth. So this has been a consistent kind of theme throughout 20th century architecture. But in the last couple of decades, I think there's been a real reaction against this whole mentality that architecture and city planning can solve real problems in a big way and can really improve the world. Many architects in more recent years have retreated from that view, and it's resulted in a more modest or inward-turning view of the architect's goals. And this is what I'll be trying to examine next time, and to suggest some of the more recent directions of American architecture that better works. So, see you on Thursday.